Teams B and C are playing World Series finals in which there's a maximum of 7 games, and the first team to win 4 games claims the championship. You have $100 to place a double or nothing bet on Team B. You must place the bet on individual games and not the entire series. How much should you bet on each game so that if Team B wins the series, you win exactly $100, and if they lose, you lose $100? Let's define states as I and J, wherein I is the number of games won by Team B at a given point in time, and J is the number of games won by Team C. Let Fij be a function which is the payoff, that is the total profit or loss from all our bets at the given state ij. We want that Fij should be equal to 100 when team B wins the championship and should be minus 100 when team B loses the championship, that is team C wins. Now we know that the first team to win 4 games out of 7 wins the championship. So when I is 4, that is the number of games won by team B is 4, and J, which is the number of games won by team C, is anything from 0 to 3, team B would have won the championship and our net payoff would be plus 100. Similarly, when J is 4, that is the number of games won by team C is 4, and I, which is the number of games won by team B, is anything from 0 to 3, team C would have won the championship and our net payoff would be minus 100. We can put this data into a table now with I along the columns and J along the rows. Each cell denotes our net payoff at the given state. Now we know the border conditions here. When I is 4, team B would have won the championship and our net payoff is shown as 100. And when J is 4, team C would have won the championship, our net payoff would be minus 100. Now using these border conditions, we need to find what will be the payoff for the remaining of the states in here. Now let's consider a state ij. At this point, I plus j games have been played and our net payoff is f of ij. Now we bet X dollars on team B for the next game. If team B wins the game, our total payoff will increase by X dollars, and we know our total payoff if team B wins would be f of I plus 1j. Since team B wins, I would increase by 1. Also, the total payoff at the previous state was f of ij. So we can write this equation f of I plus 1j, that is our total payoff when team B wins, minus the total payoff at the previous state, is equal to x, which is the amount we bet, which is the increase in our net payoff. From this we can write f of I plus 1j as x plus f of ij. Similarly, if team B loses the game, our total payoff would decrease by X dollars, and the next state would be f of I j plus 1. That is our total payoff at this state would be f of I j plus 1. Since team C would have 1, J would have increased by 1. And the total payoff at the previous state was f of ij. So we can write this equation f of ij minus f of ij plus 1 is equal to x. Since the net payoff would have decreased and this decrease is equal to x, we get this equation. So now we have two equations in f and x. We can add both of these together to get f of ij is equal to f of ij plus 1 plus f of I plus 1 j by 2, and we subtract these together to get x is equal to f of I plus 1 j minus f of I j plus 1 by 2. Now as seen previously, we know the boundary conditions of f of ij. We can put these into this equation recursively to find all of the values of f of ij, and then use those values to get the values of x, which is our bets. For example, if we take I as 3 and j as 3, we get f of 3 and 3. This is equal to f of 3 and 4 plus f of 4 and 3 divided by 2. Now f of 3, 4 is when team C wins the game, so our net payoff is minus 100 as seen previously, and f4, 3 is when team B wins, net payoff is plus 100, so we get f of 3 and 3 equal to 0. Similarly, we can plug in more values to get all of the values of f of ij. So plugging in all the values, we get this final payoff table for all the values of I and j. Once we have the payoff value for different values of I and j, we can use it to find the value of the bets, which is x, using this relation. For example, if we plug in I and j as 0, 0, we get x equal to f of 1, 0 minus f 0, 1 by 2, and these values can be plugged in from the table which we've seen previously. We get 31.25. Similarly, we plug in the values for different ij and the values of the payoff function from the table which we've just created. This will give us the value of bets for all the different values of I and j. So finally, calculating all the different values of x at different states, we get this table showing us the values of bet amounts at different states given by I and j, and this is the final answer to the question.